Finally, we get to the parabola. The parabola, I know we studied it before, but it's formed by cutting a cone at an angle, and this angle is actually parallel to one of the sides of the cone. So that makes this shape right here. And in this case, it's a parabola that's facing down. Of course, you could cut this one this direction, and that parabola would be opening up. Okay, so that's how the parabola is formed. The definition is the set of all points x, y in a plane that are the same distance from a fixed line called the directrix and a fixed point or the focus not on the directrix. So let's look down here at this example. This parabola is formed by every point that is the same distance from this focus and this directrix. Okay, so this distance and this distance are always going to be the same. That's how you get this parabola or parabolic shape. Okay. The axis of symmetry is the line that goes right through the middle of your parabola. Same thing that we learned before. The vertex, of course, is the midpoint between the directrix here, that line that we were talking about, and the focus. And then the latus rectum, so that one is actually a Latin word, latus rectum. So this one, we just call it a latus rectum, okay? Just because we're, American and we make everything shorter and easier, right? Alright, so the latus rectum is the line segment that passes through the focus and is parallel to the directrix. So this is your LR. Sometimes I'll abbreviate it by that. This is your latus rectum. It is the line that goes between, well, it goes through your focus, but it actually has endpoints on the parabola itself. Okay, it's parallel to the directrix. So looking at this, hopefully it brings back a few memories. If you have something like y equals x squared, that's going to be this shape, right? And this one would be y equals negative x squared. That's based on what we've learned in the past when we dealt with parabolas. So this one is y equals x squared, and this is y equals negative x squared. Well, by the same token, this one would be x equals y squared, and this one would be x equals negative y squared. Okay, see how that works? When you switch your x and your y, it actually makes your parabola go horizontal. So this table kind of summarizes everything for us. The equation of the parabola that is symmetric about the x-axis. Now the x-axis is where y equals 0, right? Y is equal to 0 here. If it's symmetric about the y-axis, this is going to be the general form of our This is going to be our focus, so it's the point P0. The directrix is the line x equals negative p, and then the endpoints of the latus rectum are going to be p and plus or minus 2p. And all of these work the same way, except you're switching your x's and your y's. This is the general form of the equation. The focus is 0p. This time the directrix is at y equals negative p. And we switch these. We have plus or minus 2p, p. That would be the endpoints of the latus rectum. So just until you get used to this new setup for parabolas, you might want to keep this page handy.